Okay, I think I'm recording now. We're doing a torque problem. Let me just walk this real quick. Where's the superior draw? Oh well. Here it is. So we notice our diameter is 4 meters. We pick the center as the center of rotation. These two get canceled out because they're going directly into the center of rotation, so we can ignore them. These two are acting on a lever arm of 2 meters. You know it's 2 meters because it says diameter is 4 meters and diameter over 2 is radius. So the radius is 2 meters. And then we defined our axis of rotation as clockwise is positive. This is her key. It says counterclockwise. Either one will give you the right answer. It's just making sure your signs are correct. A is going to turn it this way, making it go this way, counterclockwise, so it's negative. B is going up, making it go up that way, so it's positive. And now we will continue. We're doing our sum of torques right now. So torque from A plus torque from B. Our torque from B is going to be positive, so that's fine. And our torque from A is going to be negative, so we can put a little negative sign in front of that. Torque is force times distance.
You said force times distance?
Yeah.
Okay.
I do times right now because we're using single vectors, so it's just like 1 unit, if that makes sense.
Mm-hmm.
If you have like an ijk vector, then you're gonna make sure that it's cross, which is different than times because of how you multiply it. But for things like this, it's totally fine to just be like, it's multiplied. Anyway, this then becomes negative force A times length plus, I'm gonna write length as r because it's radius. Times force B times r. It says up there that each force is 8 newtons, and we have the same r for both because it's a circle.
16
So,
and 17.
yeah, so it's
30.
gonna be 8 newtons times 2 meters. You were saying?
Oh, no, I was just doing the calculation.
Yeah.
So for this one, is it always gonna be the radius that we solve for, and then the radius is always gonna be the one that we multiply times the force?
For this sphere, because the center of gravity is in the center, you know the radius is distance. Sometimes she'll give you something like you have an inner sphere and an outer sphere, and you have a force here, and then a force up here. In this case, the radius of this circle would be for that sphere, while the radius between the center up to here is for this force, if that makes sense.
Yeah. Do you know if we're gonna do a problem like this one? Because I feel like this one I would probably need more practice to.
Okay. I can look to see if I have one. I feel like I've definitely seen that before, but I don't remember if it was from AP Physics or from this class. So,
Okay.
but I can definitely try and do something like that.
Okay, thank you. This one, I feel like I understand it, like what you were showing.
Yeah.
I think I get it. If anything, I just need to practice it now.
Okay. But yeah, this one's just gonna be 0 because the two forces are the same. Let's see.
And then you know how for her she included T1, T2, T3. Basically for us, our T1 is like, let's say that one right No, it'll be like our so let's say I'm going counterclockwise from where A is at, right?
Yeah.
A, B, C is the one in the bottom, and then
Yeah.
D is the one the number 4, right? So our 1 would be A, but A would not be 0. Because we're
Um, the way she wrote those is just so you can see. So I guess for us it would be more like 1, 2, 3. It's just labeling which one it is.
Mhm. But when we were, if we were
No.
to solve it, do we had to write like T1, T2, T3, T4, like let's say for T1, do we had to write equals to 0? Or could we just not include it at all and just do the ones that we had to solve for?
Um, you have to make sure that she knows that you're ignoring those because you know they're equal to 0. So the way that I notated it is I did this little cross slash here.
Mm-hmm.
You could probably also put like a little note like, oh, because goes through center rotation.
Okay.
So you definitely do want to note that. Um, if this is makes more sense to you, the like writing each one out, then you can definitely do that. I was just trying to be quick with it, so I just crossed it out.
Mm-hmm. No, I like the way you did it too. I probably am gonna just cross it out and then just do like the whole solving part, like how we did it.
But if you want to be extra safe, I would write somewhere that, oh, it goes through the rotation axis. That's why it's crossed out, type of thing.
Mm-hmm. Yeah, I wrote it down right now on my paper. I put like I labeled those as C and D, and I just put C and D canceled because it goes through center rotation, so it equals to 0.
Yeah. I'm gonna clear these now. Is that okay?
Yeah.
Okay. So I don't think any of the practice from ours had a circle like that.
Maybe try chapters 9 and 10.
Okay.
Because I think for ours it was mostly on chapter 10.
That's inertia, momentum. There's a torque here if you want to do that one. That one's momentum. Yeah, she has this torque problem with the bar here. If you want to do that.
Okay.
Yeah?
Yeah.
Okay. So let's see. It says all the forces are equal to 12 newtons up here. And they're applied in different locations on the rod. First thing we need to do is pick a center of rotation, which I would honestly love to pick this side
You
because,
said to always pick the one with the most forces, no?
yeah, you should always pick the one with the most forces. This one has only one force, but because it's diagonal, you're going to end up doing two, the X and Y. And I'd rather avoid that.
Mm-hmm.
So, so that's the location that I'm going to pick.
Okay, so that would be FY4 and FYX, which are canceled that we wouldn't have to solve for, right?
Yeah.
Okay.
So you have to put a little cross, like goes through center rotation. You can also say it as rotation axis.
D, is there a way that you study like the equations that she gave us? Because there's some that she gives us like linear and angular rotation, the
Yeah.
equation. Like instead of V, it's like the omega, and then is there like a way that you learned it, or did you just like keep on repeating it or something?
Um, I made myself a little table on top of everything.
Uh-huh.
So distance, I am not gonna be able to write that well. So I'll put line for linear, and then angular for angular. Angular for distance is gonna be theta. We'll fill in the linear first. So this is, this one, x, v, acceleration. Angular is the exact same. It's just this one, then omega for velocity and alpha for um, acceleration. And I would write what it says in here.